Okay, wow. Tonight we have a really big topic. We're going to be talking about redirecting data flows and correcting errors in line in your SIS packages. So I've put together a small package here. I didn't spend too much time on it, so I don't want to get any email that, this isn't the best way to do it in production or this would be too bulky in production because I'm really just kind of talking about the concept here more than the actual way I implemented it here in like the 20 minutes I've been working on it. So what I've done here is I've generated some address data. Oddly enough, I did it with Redgate's tool. So we'll come here, and all I'm interested in right now is the states. We're going to clean up the states, and you can consider this like a data scrubbing 101 course, right? So you can see here that I've got lots of states. California is my biggest state. I got a lot of data in there, and some of them managed to do it right. Some of them kind of got it right, and others just spelled it out or flat out misspelled it or fat fingered it or something. And same thing with Florida and Texas, and one of the Texases is really bad. They missed the E in there. And Alabama goes from everything from Alabama to Alabama to AL. And this is actually pretty common when you get into some of the legacy databases and legacy apps where they have free-form text fields instead of drop-downs. So, people can put pretty much anything they want. That's the way things were done 10 years ago, right? 15 years ago. And in some companies, that's the way they're even done now. I mean, I do know of a very, very large company that is one of the technology leaders in its field, and it's still doing just that very thing. It's got free-form text fields all over the place. I happen to know that their warehouse group has to, and their reporting group has to either cleanse the data or report off of every single occurrence of this. So if you wanted to, if you were running a report against this and you wanted to do the California data, you wanted to get everything in California, you would have to put every single one of these in the where clause. Every single one of these in the where clause. And that's just ridiculous. You shouldn't have to do that. Or you would have to do a like CA. But anyway, so what we're going to do is we're going to move this data from one table to the next, and we're going to clean up all of these states, hopefully. So what I've got here is I've got my address table that I started off with there. Nothing really special about that. And I've got 4 of the states here. I think there's only 4 states in there that I've cleaned up. Now, like I said, I wouldn't really do it this way. I would probably use like a fuzzy lookup or something in production to do that, and I'll make that the topic of probably my next video. But right now, I just want to get the concept down here to show you the kinds of things that are possible. And I even left a couple errors in there on purpose. So, first off, we'll open this up, and we've just got a derived column here, right? So what you want to do is you want to take the state column, and all I did was grab this and drag it down there like that. And you want to do a replace, and there's a reason why you want to do a replace. We'll talk about that in a minute. But then right here, if you notice here, all of the Californias do start with CA. If I come back to my data set, all of my Californias do start with CA. So that allows me to really simplify this one. This one's going to be easy because first I'm going to convert them all to upper, and then I'm going to take the substring of state, and I'm going to start at position 1, and I'm going to go to position 2, and I'm saying if the substring and of starting at 1 and going to 2, in other words, the first 2 characters, if the uppercase of both of those 2 characters equals CA, then set the value equal to CA. Otherwise, I want you to set it to state. I want you to just pass the string as it is. Because you see, every one of these states, I'm going to go back to the SQL editor here, every one of these states is going to be in the string. So every single one of these is going to be in the string. So I'm saying if the first 2 letters equal CA, right here, that'll be everything in California, I want you to make it equal CA. But if it doesn't equal CA, because the first two letters of Alabama isn't CA, the first two letters of Florida isn't CA. So if they're not CA, I want you to just pass the string directly as it is and don't alter it in any way. So that's what this says. Take the substring of state, the start at position 1, go to position 2, and if the uppercase of that does not equal CA, then I want you, or if it does equal CA, I want you to to set the value to CA, and then if it doesn't, I want you to just pass the string directly as it is. The string is coming in as a length of 50. That's coming from the database. So we're just going to leave it like that for now. So we're going to pass that down to Alabama. It doesn't really matter what order they're in. I don't think they're in order in the database. It's clustered by the ID field, so it doesn't really matter what order I put them in. I'm going to do the same thing. I'm going to drag state down here, just like that. I'm not going to do it because I've already done it. And I'm going to replace state with the exact same thing, except this time I'm looking for AL. And this is the exact same logic as I used for California, only now I'm using AL. So, you know, the CAs that we've already processed are going to be in here, and they're going to be just fine. Now we're going to go to the ALs, and you know, anything that doesn't equal AL, is going to pass straight through. So even the CAs that we already did are going to pass straight through because they've already been processed. And the same thing goes with Florida, because if you look here, I've got FL and FLA and FLO. Well, of course, the common denominator there is FL. So I'm just going to test for FL again. So I'm still taking just 1 and 2. I'm doing the same replacement I did before, and I'm passing in, and I'm just letting the rest of the column pass through if it doesn't fit. So for Texas, I'm doing something a little bit different. I'm taking the first 3 and I'm looking for TEX, and I'm turning that into TX. You see here I've got Tex, and I've got Texas, and I've got TXAS. That was clearly a fat finger where somebody missed the E there. So you see here that TEX, you can see here that I'm going to miss this last one, which is fine because you can't catch everything in every single pass, and we're going to talk about that later, but right now that's the one that's actually going to get through. So from there on out, from here on out, I've got CA, AL, FL, and TX all being perfectly formatted in the codes that you see here listed in the labels, and then I've got TXAS that's actually going to get through. So what I do is I pass this through a conditional split, and I've done this really, really easily. For my simple example here, and this won't, I can easily think of examples where this won't work, but for my example here, I have set up a default data flow of cleaned, and I've set one non-default data flow where I say I've called it dirty because these are going to be the data rows that don't fit the default criteria, because I'm hoping now that by now most of the rows have been cleaned, so I can just pass them straight through. So I'm saying if the length of state, and again I just dragged state down here and then wrapped a length function around it. So I'm saying if the length of state does not equal 2, because if you come over here, of course all the state codes are 2, right? They're 2 letters long. 2 characters long. So if the length of state isn't 2, and the only one we know we have left is TXAS, and its length is 4, so we know the length is not going to be 2. So if the length does not equal 2, send it to the dirty output. Elsewise, the default output is going to be cleaned, and we're going to send it to the cleaned output. So you see here, we've got the dirty and we've got the cleaned. Now, of course, I'm going to union these because what I need to do now is I need to clean this dirty flow up a little bit. Now, I don't have to. I could just split it off. I could just spit it off into a text file or into a into an OLEDB data destination, into a table, and I could spit it back to the BAs or to the otherwise business owners to clean that data up for me, and then load it back in, have them fix it at the source. But you know, if that's not really an option, and it might not be an option, I mean, you may be doing an actual data conversion from one system to another, and you may actually, you know, this is your one pass to clean up the data. So, you know, you may not have the option of having somebody else clean it for you, but you will have the option of putting it in a table and then dealing with it later if you want to. You know, having them deal with it, and then you just write another package that comes in and scoops it up and loads up the clean data. But and I've done that down here. You see, for all other errors, I've got a little thing down here on the error operator. I've got another little destination down here with the table, with an OLEDB destination with an error table in there, and that's going to catch all other miscellaneous errors, whether they be, oh God, they could be, you know, primary key violations, they could be invalid date formats, they could be just about anything. They won't be truncations though. That's, you know, that's one thing that you need to be made aware of, which is why we've done the way we've done it here. But any actual insert errors that you're going to get are going to be caught by that, and that's always a really good idea, because it's better to catch the rows and pass and have the package pass than it is to fail the entire package and roll everything back possibly. Or, you know, if you're only going to fail 2 rows out of 10 million, you know, it's much better to come back, you know, when you get a chance and clean up those 2 rows than it is to miss a lot of rows because, you know, 1 or 2 rows failed. So, okay, so we've got our conditional split here, right here, and we're splitting off into cleaned and a dirty. And you know how both of these are coming back to a union, and that's just bringing these 2 flows back together. And what I've done here is I've written a custom component. Where is it here? It's a script component, so it's probably going to be under S. There you go. It's a script component, and I've written a transform script. So if I just drag this onto here, it's going to ask me if I want it to be source, destination, or transform. And it automatically sets up some values for you when you do this, when you choose one of these. And we're going to choose a transform. I'm going to kill this right now because I've already got mine. Okay, so when I double click on this, the fact that here, let me close it again. The fact that I've added the conditional split as an input and then taken this and set it to the union all as an output automatically gives me something. It automatically gave me the input columns, and all I had to do is come here and choose them. And I've got the input name here of input 0. I could change that in the advanced properties if I wanted. And then inputs and outputs. You see here it names all of the inputs for you. And it really doesn't do anything for the outputs because it doesn't know what you want to output yet. So I actually had to add every single one of these by hand, which of course you just highlight this and say add column, and it'll add a column to that output. So if you take a look at this, you know, its name is Street New. Its mapped column ID is 569. Oddly enough, the ID of the input is 569. So this mapped column ID, because its ID is 575, but its but the mapped column ID for your output is going to match the column ID for your input. And you have to input this by hand. You have to give it a name, you have to tell it which column to map it to, and then you have to give it a data type. And every one of these data types right here equals the input data type. It doesn't have to. You could output something completely different. But in my case, it almost always does. There's one exception, I think, where it doesn't. Yes, there's one exception where it doesn't, and that's the one I'm actually going to be working with. Well, actually, no, this one does too. So there you go. I didn't have to. I could have added that. I really could have altered that to be string 2, since we know that we're going to be taking the since we know that we're going to end up with a state code and it's going to be 2 characters. I could have put it at 2 here, but I've decided to join it into the data flow and do the conversion later on down the line. So we've got all that, and that's pretty straightforward, really. It has to have a different name than the input column, but it has to map back to the input column, and that's really all you need to know about that. So if I come back here and I get the script editor open, one of these days when the script editor opens, okay, the script editor opened. Okay, we're going to come in here in main, and I'm using the Katmai editor here again. There are some differences between Yukon and Katmai as far as the script editor goes, but you know, if you open up the main.vb or the main.cs, depending on which language you're working in, of course, then you'll be fine. So we come down here to main. Now we've only got one input and one output. If we had multiples, then we would have to deal with the multiples, and you know, I'll probably talk about that in another video, but right now I only need one output. So what I'm saying here is I'm looking inside the string, so I'm saying if in string uppercase, and I'm turning it into uppercase anyway just to avoid any problems, row.state. So I'm saying look in row.state after converting it to uppercase, look in row.state, and if it has tx in it, so if it's true that row.state contains this, and if you don't specify, it'll always start at the first character, then set row.state new equal to tx. So that's all I'm really doing, is I'm looking at row.state, which I hesitate to go back there. Okay, so here we go. So state, that's the name of the column right here, and you can see the name of the column right there. So if row.state contains tx, and remember it's starting at character 1 because I didn't specify. So if it contains tx, if that equals true, then I want to set the output row, which is state new, to tx. And then I end my if statement, so that's a single block right there. And then since I'm not really dealing with any of the others, I just go ahead and set their outputs to equal the input. So I just said, you know, row.city new equals row.city, and id new equals id, and so on. I could easily process those in the same way I processed the state column. But it just so happens that, you know, this is a simple example. I'm not really doing anything, and this could be as complicated as you needed it to be, right? Because I mean, once you get it in this editor, I mean, you've got .NET at your fingertips, so you can do pretty much anything you need to this data. You can write functions, and you can call web services, I'm sure, and I can't I can't verify, I haven't verified that you can call web services, but I wouldn't be surprised if you could add a web reference to this project. You can load external DLLs, third-party components in the project. You can write back-end data classes. You can do all kinds of things. So I mean, you've really got the full power of what you need to do right here. This is a very simple example, but the sky's the limit. And truth be told, if I were to do this in production, I would probably do here. Let's go ahead and close this. So what you're going to do is you're going to hit build. It's going to say build started, build succeeded. Okay, good. Now I'm going to close that. Okay, so that part's done. And this part right here, truth be told, these guys right here, if I were to do this in production, I would probably do it with a script component and put every single one of these into a some sort of a case or a switch statement. And I would do some fancy string manipulations in there. You can catch a lot more that way than you can here, and that way that would really eliminate the need for this guy right here, because I would have been able to fix this guy up here, because this guy would have been up there and I would have just handled all of those cases inside of my custom script component. But what you could do here with this fixed leftovers, instead of handling something that you didn't handle up here in the text, you could use it to, if you get an error, if you check for errors, you can check data types, and you can check all kinds of things to make sure that they're going to go one column at a time to make sure that they're going to go in the database. So you can use this custom script component as a bulletproof way to make sure that the data is going to go in there. And of course, you could do that with the GUI too, right? I mean, you could you could use the data conversion like we did down here. So on with that. So we've covered the custom script component. We've covered the conditional split, and now we're feeding them both into a union all. And one thing about the union all, don't forget that for the input that's coming in from here, don't forget you have to set this to the new, especially for the state. You don't have to set it to the new for the other ones, because you still have the plain street, because it just passed through. So you just have the plain street, but remember, that's not going to do anything since we're about to do our data conversion. That would actually blow this script up. And I just set them all to new, so that if I ever do want to come back in here, let's see if I can get this guy to open in under 10 minutes. There we go. If I ever do want to come back in here and mess with any of these guys and alter them somehow, I don't have to come in here and mess with any of my downstream components. They're already set to accept those values. And if you have to touch the ones in the custom script component, you don't want to have to touch the downstream components too. It just makes debugging a lot harder, and it blows up your metadata, and sometimes it takes a while to get things right again. So I like to set all those things up front, and then if I have to mess with the upstream components, then it doesn't affect the downstream components. Now I've got a data conversion here that's set final type. And you notice I'm passing everything through except state, in which case I am changing the length to 2. And it's still, it's still a string, but I'm changing the length to 2. If I leave it at 50, like it is up here, and like it is up here, and like it is everywhere else, because that's the way it is in the source database, and I couldn't possibly change it to 2 here. I mean, I could have changed the output to 2 here, but it wouldn't do me any good, because I would have truncation there, because I still had, even though I converted all of the Californias to CA, the Alabamas and Texases and Floridas were still much longer than 2 characters. So I would have truncated those, and while in my example that really wouldn't hurt anything, right? um, you can, when you get to some of the other states that are more ambiguous, well, like even if I added Alaska, if I had variations of Alaska and Alabama, and you truncated it, if you truncated the output right here to 2 characters, you wouldn't be able to tell the difference between Alaska and Alabama. So it's best to handle those separately and keep them at the full length until every single one of them have been taken care of, which is what we're doing right here. If I didn't have this here, the package would still run, but since this is 50 and the final copy, the final table is the state is character 2, because that's what you want it. You want it to be character 2. There's no reason to have it to be varchar 50, because every single character is going to be 2. So since every character in your final table is 2, you might as well convert it here and pass into, and now the metadata is great, everything's fine, everybody's happy, and your package should run without any incident. And but like I said, if I didn't do that data conversion there, it would just give me a little it would just complain right here. It'd give me the little caution flag and say, data may be truncated. Yeah, it might be, but it's not really anything you'd be concerned about, because all of your data is clean by now. But you like a nice clean package free of errors, right? I mean, you don't want to, especially if you're doing package logging, you don't want to see that truncation warning every single day when you go to look at your log. It just gets old. You want to keep your log, clean, so that you can watch out for real errors and real warnings. So, and then like I said, here on the end, I've just got this error table tacked on the end there to catch any miscellaneous errors that I haven't thought of, or that get introduced by some new coding error that somebody's introduced. You have no idea, what the source database is really like. So somebody could introduce a mistake that in the last 5 years of running this package you've never encountered. So rather than fail the package, it's always best to it's always best to tack something there on the end to catch the miscellaneous errors. Now this one won't error out, and this table looks exactly like the address final table up here, only it's got 2 extra columns in it that the error handler adds. But in production, and like I said, the error table looks exactly like the address final table. In production, I would make those all varchar 255s or in varchar 255s, because if it blew up here because of a date conversion, you're not going to be able to insert it here if the column is the same format. So you'll want to spit everything out into strings, and really big strings. Now you could use varchar max across the board if you wanted to, just to make sure that whatever is blowing up in your destination is going to be able to go into your error table without any problems. So anyway, like I said, I wasn't worried about that here. And let's go ahead and run this package. Let me save it just in case I did anything funky. And let's go ahead and run it, and we'll watch this ballet unfold. Right there. And I think I've got something like 6 million rows, 6 million and change, something like that. And this is on my workstation, so it's going, from this box to this box. So there are going to be some disk contention problems and some memory contention problems, because not only am I doing it on the same box, and input and output have to share the same memory, but it's got to share it with Camtasia as well. It's also trying to record it at the same time. So cut the speed a little bit of slack, but it's still it's at 1 million rows right now, so it's not doing too bad. So I guess if you like, I can sing you a song while we wait. But I won't. I'll spare you that. And for those of you that are curious about the title of this site, Midnight DBA, it's true. What I said on the front is true. It's midnight 30 here, and the rest of the family's in bed, and I'm sitting up making videos while it's nice and quiet. Keep having to periodically pause the video because I'm yawning because it's a little late for me. And see there, we're 2/3 through. Now at the end here, you're going to see that that last Texas thing that didn't make it through, that made it through every one of these guys intact and got split off for on the dirty split. You're going to see it get fixed and merged back into the data flow. It's actually pretty slick, and I've done stuff like that with conversions, with date conversions in production scenarios where I've actually had, see there it goes right there. So we had 1,000 of those rows, and 61, 45, 600. Right here, 61, 45, 600, 61, 45, 600. Let me move that so you can see it better. There you go. And there you go. That's a nice little flow we got going on there. But yeah, I've done this in production where I've had the same thing, where I've had, you know, legacy dates coming through, and legacy dates are usually just horrible, especially in healthcare data. You've had nurses and receptionists and everybody entering in dates for things. And you know, you'll get, you know, the year 206 or 197, or you know, the month month 112, or day, you know, 223, and you know, you've got to find a way to clean that kind of stuff up. Now, what's interesting is you can do this kind of thing with text files too, but it's a little bit different, and maybe I'll make that one of my next videos, is how to do this with a text file, because it actually does change a little bit, not drastically, but enough that you need to know how. And I actually think I remember saying that I was going to do the fuzzy lookup next. So maybe I'll do fuzzy lookup tomorrow night, and then I'll do the text file the night after that. Anyway, this is how you do some basic data cleansing and SIS, and have it fix the errors in flow and add it back to the main pipeline, and pump it into the table. Hope that some of y'all got something out of this. If nothing else, some good ideas. You know, again, you know, do as I say, not as I do. I wouldn't use all of those derived columns for the states like that in production. I would use the custom operator or the fuzzy lookup. So you know, happy SISing, I suppose.